Thank you so much. It's indeed a pleasure. And we do have distinguished speakers today to talk about truck platooning. I will not take any time except just to go and dive in and listen to four amazing topics today. And they are all go in series in a way to explain all the benefits and the challenges that we are having as we are moving on to truck platooning. So I will start with our first speaker, but please make sure that if you have any questions, you put it in question and answers. And because this is a panel, we will have the discussions at the end of the four talks. So first, we'll start with Richard Bishop. Richard served as the principal for Bishop Consulting, which provides strategy and partnership development in the domain of intelligent, connected, and automated vehicles. He is advising the automotive manufacturers, suppliers, tech firms, and government agencies. Mr. Bishop serves as the second vice chair for the American Trucking Association's Automated and Electric Truck Study Group. Prior to the establishment of the Bishop Consulting in 1997, Mr. Bishop was program manager for vehicle highway automation at the US DOT Federal Highway Administration, where he was government lead for the National Automated Highway System construction. So, Mr. Bishop, the floor is yours.
Okay, Imad, really nice to be with you here and be with all my colleagues. I'm really looking forward to the discussion. So I'm very quickly going to provide the broad perspective in terms of automated trucking generally and where platooning fits in. So let me jump right in. A couple of macro trends that speak to the larger world. Automotive OEMs are developing autonomy for private vehicles, and they're going to offer that at their own pace. So that's another world. But what's key to our discussion today is that fleet operations are completely where the action is, whether it's robo-taxi, robo-delivery, robo-truck, you name it. And driverless robo-taxi has already been launched. We are in the driverless area, the driverless era. There's strong momentum in driverless goods movement. And let me give you that sort of big picture. 4 areas: controlled environment, streets, resource roads, and highway. Let me start with streets. Obviously this is a complex environment, very low speed. It tends to be customer facing. So you have to get to the customer wherever they are, which can be complex in terms of the road network, but it's very strong market and growing, particularly because of the COVID pandemic. There's the B2B world. There's some key players there in terms of goods movement, parcel delivery. Waymo has created a new brand called Waymo Via that's for goods in particular. They are working with UPS. Gatik is definitely one to watch. They are working on the street level, the short runs between, say, a Walmart distribution center and a Walmart retail store. So they're not facing customers, but look at who they're working with: Walmart as well as Loblaw. Loblaw is generally seen as the Walmart of Canada. And they have announced they're deploying driverless in 2021. So they could be the very first to go driverless with goods movement. They're going to do that in Arkansas. Einride is another one to watch. And then in the B2C world, going to individuals' homes or whatever, Neuro is by far the leader there. But moving into sort of the larger vehicles, in controlled environments, we have logistics yards, semi-controlled industrial roads, as you can see by this indication of the Volvo Vera autonomous drone, which is just a concept vehicle, but they might bring it to market, moving containers around. The issue is that even though there's a high user need, there's a small market relative to the over-the-road trucks. And so it's been a little lower tech because the OEMs haven't invested in it over the years, but of course that's changing. A key player illustrating what's happening here is Outrider. They are operating within the yards, as it's called, the distribution centers where trucks are shuttling trailers between loading dock doors and storage yards. So it's off the public road. It's a very simple operational environment. They are moving along quite well. They've announced Georgia Pacific as a customer. I recommend you take a look at their webpage. They've got some interesting videos to show what this is all about. But what they're able to do is not only automate the vehicle, but also automate the connection of the brake line, the air lines to the trailer and hooking up with a robotic arm. Now, resource roads don't get talked about as much, but they're getting very interesting. You know, this picture says it all. It's a classic unpaved road in a very remote area. The speeds are medium, and again, this is a small market, but we're talking timber, mining, etc. FP Innovations, Forest Product Innovations, is a Canadian non-profit research center funded by the Canadian forest industry. They've got a pain point with a driver shortage. Everybody who's moving goods has a pain point with driver shortage. And so they want to look at automated follower platooning as a way for 2 loads of timber, fresh cut timber, to be moved with 1 driver. It's more than just talk. They're launching a project this year to adapt the commercial systems out there for rural public roads. They've already selected their contractor. There'll probably be an announcement of this in the next month or so. But let's get to the highway. Here we have a very well-ordered environment, at the same time, very high kinetic energy because of the speeds. The market is huge. And there's 2 key operational modes. There's platooning that we're here to talk about today, and there's what I call solo driverless. And let me get into both of those. Just to be clear, for the sake of our discussion, some basics on truck platooning. It's all about close drafting between 2 trucks, generally, maybe more than 2, done safely. Drivers try to do that now, and it's not safe if the front truck suddenly breaks. But the whole point here is to reduce fuel use. Typical numbers are about 4% benefit for the leader, 10% for the follower truck at 60 feet at 60 miles an hour. This is all enabled by connected braking between the trucks using low latency vehicle-to-vehicle communications. DSRC has been used up until now, and other communications approaches could be used as well. The commercial systems in the US, at least, focused on multi-lane, divided, limited access highways. And any cut-ins by other vehicles are a key part of the safety case. The systems are designed to handle that. We're looking at 2 generations that are both in development. First generation, level 1 platooning. The front driver still steers normally, and the rear driver is very much in the game. They're steering, monitoring the road, responding to other traffic. The second generation basically removes that rear driver. And that, of course, adds a labor savings to the already existing fuel savings. Here are the players that I know of that are working the space. Peloton is working both level 1 and level 4, or 2nd generation platooning. Locomation is working on the driverless follower, 2nd generation. And robotic research is actually very active with the US Army. They have delivered 100 trucks to the Army for evaluation. That's now proceeding into a large procurement of thousands of trucks from the Army that's expected this year. We've also seen various truck OEMs demonstrate, at least demonstrate and do some maybe extensive testing of platooning. Trayton Group, the Volkswagen spinoff, Volvo, as well as Daimler Trucks. Daimler said a couple of years ago they were stepping away from level 1 platooning, but they left the door open to the level 4 platooning, the 2nd generation. I would think the business case is so good for driverless follower platooning that all of the OEMs are seriously considering bringing it to market, and they certainly have the technical ability to do so. A key point to understanding platooning is it's not about being in the wild and trying to find some other truck that's able to platoon. The initial use case is within the same fleet, hub-to-hub routes. There are tens of thousands of trucks that operate this way. They generally depart their launch point within minutes of each other, so there's no delays or whatever in actually creating platoons. Now, in the solo driverless world, we have these sorts of players. I won't go through all this. Just the point is that if you look at the money invested in truck tech, it's really mainly in this solo driverless world where an individual truck is moving driverless. I'll finish with this point specific to our topic. Where does connectivity fit in the automated driving ecosystem? On the left, I'll say that the ADS safety case, automated driving safety case, must rely fully on onboard equipment. It cannot rely on any external communications, including global navigation systems. So that's a given. These systems will be connected via cellular and cloud for purposes of efficiency and monitoring, but not specific control critical things. So on the right side, when we talk about low latency V2V, it's a niche when you look across all that's going on in automation. However, truck platooning is a key, if not the key place where this V2V communication is needed. Now, the issue here is, unlike what you've heard about with basic safety messages and all the standards from SAE, there's no need for all of that. This is a closed system providing the data integrity. So truck platooning is a key match. Cooperative adaptive cruise control and light vehicles could come along, but there's not a lot of momentum there. So, and finally, low latency V2X provided by the infrastructure, to my understanding across the industry, is not seen as essential. The public agency data is highly valued, work zone data, et cetera. The sense is that can be provided via cellular. And on the street, of course, traffic light data is valuable as an additional data source, but not seen as essential. So we can get into that as we discuss and maybe debate that a bit. Thank you.
Thank you so much, Richard, and we'll get back to you as we are going through the discussion. Thank you for very exciting presentation. Our next speaker is Marcia Gilder Murphy. She serves as the Regional Director for Luckmuller Group's 5 offices in the states of Missouri and Illinois. She has over 20 years of engineering and construction industry experience. She currently serves as the chair of the ASCE Public Policy Committee. She's a member of the Missouri University of Science and Technology Academy of Civil Engineers, which recognizes outstanding achievement, excellence, and leadership in engineering and civic affairs. She is a licensed professional engineer in 7 states. In 2016, she received the ASCE Edmund Friedman Professional Recognition Award. This is a very prestigious award, actually. And in 2010, she received the St. Louis Most Influential Women Award. So, Marcy, the floor is yours. Yep.
So thank you, Imad. Let's start over. I'm going to be talking about the specifically the freight considerations when it comes to autonomous truck platooning. Our company is very involved in the supply chain and logistics, focusing on optimization of freight movements. So I wanted to talk about a couple of things. Number one, the impacts of COVID to the freight industry, only because I think it's profound that we have a lot of people that are using e-commerce. And so one would think, oh my goodness, you know, all of a sudden we have an increase in freight, which is true. However, everybody was impacted by the current pandemic. And while the freight movement decreased by approximately 8% over last year, the projections are that it is going to surpass pre-pandemic activity. So it is very elastic and is going to bounce back very quickly. I also want to talk about the truck industry and the market share and key areas for implementation. Number one is the proof of concept. Basically, what policies will the federal government develop and what will the timeline be? We have regulations that vary widely from state to state, and we're going to have a meeting of the minds for this to be successful. According to the freight leaders that I have talked to, we're at least 5 years away from platooning technology being fully embraced. And by that, I mean accepted, not actually fully implemented by the market. And the main reason is how fragmented the market is. And I'm not sure if everybody understands how much this industry is fragmented. It's a $900 billion a year business. However, the top 5 carriers, the J.B. Hunts of the world, only have 8% of the total market. The rest of the market is small to mid-sized companies, most with 30 trucks or less, or owner operators. So we need a product that, as I said, would be embraced by the small to mid-sized market. Autonomous truck platooning and autonomous trucks will likely shift the owner operators to focus on the short haul, and the top carriers will focus on the long haul. The top 3 challenges to compete in the market, as reported by the trucking industry right now, are driver-related costs, insurance costs, and technology investment. With level 4 constrained autonomy, operating costs would decline by about 20%, saving the US for hire trucking industry between 150 billion to 180 billion. So the economic incentives are there to automate from a business perspective. However, the truck driving industry is deeply traditional. So a culture change or paradigm shift will be needed and will take time. So the driver impacts, often you will hear, well, what about the drivers? What's going to happen to the drivers? And as you heard when Richard was presenting, that the shortage of drivers is severe. So this technology will actually supplement the crisis that's happening right now with the shortage of drivers. The average age of a driver right now is 58, and as they retire, they are not being replaced. The current driver shortage is approximately 63,000. More drivers are needed, and unfortunately, because they're not being replaced, that number is increasing. With baby boomers retiring and few millennials willing to endure the long haul lifestyle, it is a very difficult lifestyle, and with many hardships, being away from home for weeks at a time on cross-country deliveries. It's estimated that by 2026, the driver shortage is going to be over 175,000. The chief economist with the American Trucking Association, Bob Costello, said he's never seen anything like this before in the history of trucking, where you have demand is strong and high and capacity is constrained. With long haul driving hours being able to be increased with ATs and platooning from 11 hours to 20 hours, fleet sizes in some cases would not have to increase to meet the additional demand. And it looks like the shift is going to be, as I said, where the small to mid-size will do the short hauls. So the long haulers will be platooning and exit to a staging area, and then the short to mid-size drivers will then drive them to the ultimate destination, navigating streets, local and pedestrian traffic, parking lots, and loading docks. Lastly is insurance. So this is truly going to be the most impacted industry, which most people don't realize. They're always focused on the drivers. This industry is going to be impacted because the regulatory environment is going to shift to account for unforeseen liabilities presented by this technology and by ATs, who is involved in the collision, who is liable. Trucking insurance coverage will also have to adapt to the new operational environment, protecting truck companies and their employees against liability risks. Given the complexity of the technology and liability issues involved, it's entirely possible that vehicles will be owned by the manufacturers, leased on a long-term basis to the transportation companies, and property and casualty insurance carriers and agencies will transition from selling to consumers to selling to makers of the autonomous vehicles. To navigate that change successfully, insurers will need to know as much as possible, as rapidly as possible, to adapt to their markets. And that's all I have on the freight industry side.
Thank you so much, Marcia. I really appreciate this. And I think that's gonna bring many questions. Our next speaker is Christian Haas. He is a professor of quantitative research methods at Princeton University and director of the Institute of Complex System Research. He's part of the House of Logistics and Mobility, HOLM, team in Frankfurt, Germany. His research topics are human-machine interactions, neurophysiology of human behavior, digital transformation, and autonomous systems. He is a member of the research board of the Association of German Transport Companies, and he coordinates different research and development projects funded by the industry as well as the government ministries. Christian, the floor is yours.
Yes, good afternoon from Germany. Hello, can you see my screen? Can you understand me?
Yes.
Okay, yes. First of all, thank you for the invitation. I would like to show you some of our results of our platooning study here in Germany, and I would like to put an eye especially on the driver's behavior. So what did we do? So overall, we did 35,000 kilometers of platoon testing here in Germany on a German highway between Munich and Nuremberg. And within this 35,000 kilometers, we did 5,000 kilometers with special neurophysiological analysis, which means brainwave analysis and eye tracking. We used normal truck drivers, which is of pretty importance for this kind of testing here that we did. We used a two-vehicle platoon, and we set the speed at 80 kilometers an hour, and the distance between the two vehicles was 15 to 21 meters. So first of all, I would like to show you some very simple, but I guess important results. So we did not find any significant differences in subjective sleepiness between driving as a platoon leader, driving as a platoon follower, or driving solo under normal conditions, which is of course important because sleepiness is often discussed as a risk factor in autonomous driving and also in platooning. So we did not find any significant differences here. Our brainwave analysis shows also the same picture. So the relative band ratio, the ratio between the theta frequency waves, the alpha frequency range, and the beta frequency ranges shows no difference between driving solo in a solo truck, driving as a platoon follower or as a platoon leader. So the theta frequency range stands for being tired, being fatigued, being sleepy. The alpha frequencies stands for being relaxed, and the beta frequency range stands for being alert. So we did not find any significant differences between the different driving modes, which is a good result for us here. Let's now have a look at our eye tracking data. So we compared the gaze distribution, which means the relation of having a look at the HMI, having a look at the road ahead, or having a look at the mirror, and we compared different driving situation, which is normal platoon driving, the coupling situation, and the platoon decoupling situation. And during normal platoon driving, the eye tracking showed no significant differences between looking at the HMI, looking at the road, or at the mirror. However, at the platoon coupling situation and at the decoupling situation, which is around about 30 seconds, 25, 30, 35 seconds, we found that especially at the platoon leader, the relative amount of looking at the HMI was longer, which of course could be a critical factor because the duration of looking at the road is of course reduced. However, there's a very simple solution for this kind of problem, because the driver, especially the leader, has a look at the HMI because relevant information about the platoon status is presented here at the HMI, and one could of course put this relevant information in the head-up display in future, which might reduce risk in future than there. But however, one should keep in mind that especially the task switching situation is of crucial importance. So the normal platoon driving seems to be safe, or seems to be comparable within the looking behavior, the eye tracking data. The task switching situations that there is a difference becomes also obvious when having a look at the driving behavior. So we analyzed, for example, the lane keeping pre-platooning and post-platooning in each and 5 phases. So after the so these 5 phases are the pre-platoon phases. So the trucks are driven under normal conditions, and these 5 phases are after decoupling the platoon. And it becomes obvious that after having decoupled the platoon, the lane keeping shows a larger distance compared to the pre-platoon phase, which means that the driver has learned during the platoon driving, or has adapted during the platoon driving to the autonomous driving of the truck. And after this phase, it takes some minutes that he learns again that he has to keep the lane for himself then again. So to summarize, for us, we found a lot of data which shows that platooning is relatively safe, but however, you have to especially have a look at the task switching situations in future and develop the technology, especially having a look at this switching between the different tasks. That's from my side. Thank you very much.
Thank you so much, Christian. Appreciate also you stick to the time. So we'll go to our next speaker. Srindhar Lakshmanan is an educator, researcher, and faculty member at the University of Michigan, Dearborn. He's also an inventor and entrepreneur. In 2002, 2 years before the DARPA Grand Challenge, his company, M-Vision Incorporated, fielded a system to steer a 20-ton driverless U.S. Army Stryker vehicle at highway speeds. He serves as an advisor to the City of Detroit's Public Lighting Department and Authority. His work has been used in the city's historic bankruptcy filings in federal courts and in the system-wide overhaul of the city's streetlights. He has received several awards, including the 2001 IEEE Best Paper Award from the Vehicular Electronics Society. The floor is yours, Srindhar.
Thank you all for attending. I'm going to build on some of the panelists' previous discussions. I'm particularly going to focus on the V2E portion in fuel efficient platooning. I'm Sridhar Lakshmanan, and let me give you a quick video to sort of show the project that I was involved in. So in this project, we have 4 semi-trucks. 2 of them are military vehicles made by Freightliner. 2 of them are commercial vehicles made by Peterbilt. And these vehicles use a cooperative adaptive cruise control in order to platoon. So the lead vehicle is manually driven. The following vehicles have a safety driver in them, but they're otherwise autonomous. So the steering, throttle, and brake are autonomous. And this is facilitated by a traditional adaptive cruise control system that has a radar doing ranging with the vehicle ahead. And then layered on top of it is a very precision GPS system, and then a V2V cooperation between the vehicles. And we provided an embedded software layer for the system that resides on the radio network or on the radios. And we essentially talk to the controller. So this is work done with Auburn University. I'll come to the collaborators at the end. So we talk to the controller at one end, and we pass messages through the air to the other controller. So we are passing somewhere between 7.5 to 8 kilobytes of information every second. And it is in this context that we've done some studies, and we've done a lot of testing, both in test tracks, like at ACM here locally, or at the National Center for Asphalt Testing in Auburn University. We've also done some public road testing in Michigan, in Alabama, in Canada, where Richard mentioned logging roads. And we've spent a fair amount of time in the last year or so studying the effects of various things on this V2V network, if you will. To sort of get into some of the weeds, I've shown here some of the details. So in terms of antenna positions, we've looked at high antenna position, which is about 13.5 feet from the ground, to a lower antenna position, which is only about 8 feet from the ground. We've looked at occlusion effects. We've looked at weather effects, and so on and so forth. We've looked at road curvature, both road grade as well as regular horizontal curvature. And here are some of the results. I'm going to give a teaser as to some of the results and refer you to papers that we've written for more details. Of all the things that we've studied, occlusion is the single most important consideration when it comes to V2V efficacy. You can see here that this is a 2-mile loop approximately. On the straight segment of the test track, the received signal strength between the radios is negative 67 dBm. The units are not that important. The only thing is that around the curves, the received signal strength improves by about 15 dBm, 15 dB, which is very, very significant. And you can sort of appreciate what is happening here, why the curves give you a much better signal strength than the straight roads. And that's why I put this figure here, is that you can see these antennas are in the shadow of the trailer. So when these trucks are following each other, this trailer here presents a big non-line of sight occluder for the antennas. Whereas when you go around the curve, the articulation of the cab with respect to the trailer implies that these antennas now have a straight shot at the follower's antenna, and so your signal to noise ratio or the received signal strength significantly improves. So that's one study, and again, we've published this study it's going to appear in the World Congress of 2021. I encourage people to go there if you need more details. We've looked at some weather effects. So far, we have not seen much difference with respect to weather. We're going to do some more testing this summer, so hopefully we'll have a little bit more insight on whether rain really affects V2V performance. No, this study is at the vehicle level, at the radio network level. We've also tried to determine what the effect of some of these things might be at the fuel economy level. So here I do a teaser, if you will, again. On the left is we wrongly mounted a radar on the follower vehicle. So it is disoriented, if you will, compared to normal. So that's what we call a faulty radar. And then a valid radar would be one where it's mounted properly. And there is a big difference. These trucks are following each other at around 50 feet. And so a wrongly mounted radar has problems around corners. And so that the fuel efficiency takes a big hit, as big as 50% in this particular case. In contrast, we placed an interference device, a local interference device that created a sort of an interference cloud in a segment of the test track. And we measured its effect on the radio network performance. And so far, with these localized interference, we have not seen discernible difference in fuel efficiency as a result of whatever effect that interference may have on the radio network. And finally, we've studied this since non-line of sight is our biggest affector, if you will, of radio network performance. We have studied this non-line of sight problem in much more detail. We've studied the so-called single obstacle problem, one where there is a large vehicle or trailer between the antennas, creating a non-line of sight. We've also studied urban canyon side of scenarios where there may be buildings or other types of vegetation, for example, that might create these non-line of sight scenarios. This is a recently concluded CCAT work, and we looked at performance of both traditional DSRC radios as well as CV2X radios, and try to measure quantitatively how different they are, etc. And we can get into the details of it. Details of it is available in a final report from CCAT, but if necessary, we can get into it. And so this is the type of work we've done. It's at a much lower level and at the weeds, if you will, compared to the type of work Richard has been presenting. And I'm happy to talk more about it if you have questions. And as backup, I have the paper so I can get into the weeds if necessary. That's all I have.
Sridhar, thank you so much. We really appreciate it. I think we have 4 excellent presentations, and many of the questions have been answered directly. So we'll go to the questions that have not been answered. And I'm going to start with you, Sridhar. How do you see the FCC ruling on the 5.9 gigahertz band affecting the future of V2V enabled platooning?
Oh, it's a loaded question. I mean, as many of you are probably aware, there is a recent notice or along these lines from the US Department of Transportation. Clearly, the opening up of the channel will create interference at one end, and depending on whether it's on the same channel or whether the baseband is on the same channel or on the adjacent channel, it can also create some congestion issues. So, broadly speaking, this new FCC ruling is going to make V2V communications more difficult in public roads as a result of interference and congestion.
All right, thank you.
I could add to that if
Richard,
you'd like.
do you want to add, please?
Yeah, just briefly. From what I hear from the platooning developers, they would like DSRC to continue to be available, but they can adapt to CV to X. There is some concern about the right kinds of radios and being actually available on the market, that maybe the FCC action was premature. But the other really important thing to understand is the FCC is, you know, their decisions, their past decisions can be changed, and that is certainly under discussion under the new presidential administration.
I think, Richard, that came also a question in the chat for you, which is, you referred to communications for platooning as a closed system. Does that mean it does not use either CV2X or DSRC? What spectrum does it use? So it's within the same line. How is it protected from the, random interference or even deliberate jamming?
Right. To be clear, DSRC is being used in the allocated spectrum as it is now. So that's very much the case. It's closed in the sense that the point is not to share with every other vehicle on the roadway. The point is to share only with your partner truck. So there's a lot of cybersecurity built into that. You know, you have a more secure system because you're not just broadcasting broadly. You're locked in to your other player. If for any reason, at least from working with Peloton, you know, the question has come up of if they lose the signal for any reason, jamming or just whatever, the system can detect that. The trucks open up in a level 1 system, at least with the driver in the rear vehicle, they can resume driving. I don't have a specific answer on the driverless follower, but I'm sure that's in their engineering requirements to handle that.
Right. Thank you, Richard. I think that brings a question for Christian is, you mentioned that the attendance of the drivers as a lead or as the other drivers are in a way similar. Is that the same regardless of the number of the trucks in the platoon?
So we did our analysis only with a two vehicle platoon. So we don't know if there would be a difference in a 3 or 4 or 5 vehicle platoon. Of course, the infrastructure situation is different in Germany. The German highways are different than the US highways. Of course, speaking about the speed of the cars, so normal cars are allowed in Germany on some highways to drive 200 kilometers an hour, 250, so open end, so to say, and that's of course pretty hard to handle it. But we don't know about the difference. However, I guess there would not be really a difference of the first platoon follower and the second and the third. So I guess it's the same kind of situation for them. Even if the neurophysiological data could be interpreted as being as showing the same behavior, we are the opinion that it's not, of course, the same behavior between normal truck driver or normal truck driving and driving in a platoon, but it is the same kind of controlling the system. So the neurophysiological data is, so to say, a symbol of controlling the system or trusting the system. And a normal truck driver trusts his truck and he controls his truck. And during our platooning tests, the drivers were fully aware that they could trust also the truck. So it's a question of trusting the technology, trusting the truck, and having a kind of feeling that one can control the system.
Thank you. Mercy, that's a very interesting discussion you had about the insurance. So as you well aware that safety is very important, and there is more than 4,000 fatal accidents by trucks every year at the cost, each one is more than $7 million. The question is, 94% of these accidents are human related. So the question, if you have platoons, wouldn't you think that this is going to be better for the insurance? I mean, what's your take on that?
Well, I agree, Imad, and that's where we always have to go back to the proof of concept. So it's going to be what can we show, right? And it's a complicated situation because we're going to be implementing this system, and where can we implement it, and where can we get the data to show that this actually is a safer mode, so that the insurance company can have a proof of that when they're adjusting their rates. And that's why we believe, and the industry leaders that I've spoken to believe, that it is going to evolve to the larger manufacturers are going to be the ones who will take care of the insurance to sort of propel, if you will, accelerate the use of this and the technology. With all of this, Imad, it goes back to, we understand the technology is moving at a certain rate and we're going to have a certain ability, but is the policy, the government policy, is the culture going to move as quickly to embrace the technology? And that's an ongoing issue, regardless of what technology we talk about.
I think the following question is a follow-up. It's maybe related to policy, but also Richard may also chip in here. You mentioned that almost 92 of the trucks are owned by medium and small companies. Are we seeing in the future that there will be collaborative work between all different companies to do the platoons? Like, for example, a truck from company A work platoon with a truck from company P as they are driving on Interstate 57 until they reach different destinations and so on. So I think this question's to both you and Richard, because it's policy as well as I guess. Yes, go ahead, please.
Right, and Richard can weigh in more. He has far more expertise on this than myself. However, I will say that the concern is that the large carriers are going to monopolize the market, even though they've only got 8%. You know, so we need to be mindful of that. I don't know how they are planning to cooperate. I will leave that to Richard. However, for full embracing and implementation of it, we do need to keep in mind that 92% of the market is carried by these other carriers.
Right. Richard, do you want to weigh on this, please?
Thanks. I'll add a couple of things. You know, when you're a technology developer and you're bringing something to market, you look at, is there a big enough market for me to launch? And that's why they're going to look at these relatively few big carriers, but in terms of volumes, huge volumes. So there's enough to launch this platooning market amongst the large carriers. You know, UPS and FedEx each have 25,000 tractors, for instance. It's very different from Europe and really anywhere else in the world. So that's the key. and initially, as I said, these trucks will be linking up in a within fleet sort of mode. It's the simplest way to start, and there's plenty of operations like that. It's certainly technically possible to do the sort of matching up in the wild. It's, you know, the issues would be handled in the back end in terms of who's in the front and who's in the back, because they get different fuel economy numbers there. Are they willing to your question? Just an anecdote, you know, I was talking to a couple of guys, one from FedEx, one from UPS, and they said, would I platoon behind my competitor? And his answer was, yeah, because running alone, I'm going to get worse fuel economy than running behind this UPS truck.
Yeah, absolutely.
Let me
Yeah,
let me give a comment on that. To me, it's also an important question of trusting another guy who I've never seen before. So in our tests, the truck drivers knew each other, and that was, of course, important. So they had a lot of experience of driving together, and so they trusted the other truck driver. And now different trucks meet somewhere on the highway, and the big question for us is not the technological. Of course, it is also important, but there is another truck, another truck driver. So that's pretty hard work it's not an easy answer how we can, so to say, showing a roadmap for trusting other people.
That's a good point, Christian. And along those lines, the liability insurance will weigh in on that as well.
Yeah, I think
Peloton has had a concept in place of an operations center that will kind of work the trust issues, not just the individual drivers, but their level of training and the level of maintenance, quality and that type of thing.
Yeah. Sure.
Yeah, I'm seeing in the future that there will be a list of A, B, and C, and D of the trucks that you can follow and you cannot. So that being said, I think, Christian, the other question was for you, actually. 2 years ago, there was a paper published by a very respected university in the US talking about the drivers now, truck drivers, they don't like this job because of the back pain, the lower back pain, and they are citing this as one of the reasons that we are losing truck drivers. Have you done something on this in Europe, or are you aware of such an issue in Europe?
So I don't know about specific data, biomechanical data, health data in truck drivers. However, there are a lot of studies in bus drivers, and of course, it's the same or nearly the same. So back pain is one of the main problems in these kind of working conditions. Yeah, but I'm not really sure if it's really the largest problem for the truck drivers. I guess some of them, of course, they accept the pain.
Right.
I don't have precise data, but we did some studies in a comparable field, and we found there that a lot of people working under comparable conditions, they accept the pain, of course, but other parts of the job being recognized, having a reward, and reward means not only a financial reward, but also a kind of reward by the society. These are more important aspects than reducing back pain, which should not mean that back pain is really of low importance, but
right,
it's part of the game, so to say.
I understand. I think the last question here is for Surinder. You have done some field studies, and the question is, did your team look into the impact on the infrastructure and how this is going to be impacting the cost if it's either for bridges or roads?
Not sure I fully understand the question. What do you mean impact the infrastructure?
The infrastructure I'm talking about, as you are doing the platoons, there will be an impact on the bridges and the roads because of the load that it's applied within a shorter distance. And I know you have been doing some work, you said on test track. Have you looked into that, or that's out of your field.
Yeah, no, that's much beyond our scope. I don't think within our group of people, any of us have looked at the impact that platooning would have on the existing infrastructure like bridges or road pavements, etc.
Maybe I can add to this question. Were you looking at the distance between the trucks? I mean, the optimum distance between the trucks that you were platooning during the testing?
Yes, I mean, so from a fuel efficiency standpoint, I think the closer you can platoon, the higher the fuel efficiency up to a certain point.
Right.
So I think 30 feet is where, if you get closer than 30 feet, actually the fuel efficiency goes down, becomes worse. And if you go beyond 250 feet, there is very little effect. So in that 30 feet, 250 feet, it's monotonic. The larger the distance, the less the fuel efficiency gains.
Right. Okay, I think we are just about here to conclude ours. I can tell you this is the most amazing panel I ever served on, because I never serve on a panel where the members are much quicker than the moderator in answering the questions on the QA. So I really admire you for this. So I wanted to thank you all for being with us. That was amazing presentations, and the question and answers. You were ahead of me, that's all I can say. So I'm glad that I have backup questions. So that being said, I thank you so much. And by the way, we will be having after a month a complete report about the platooning and the number of platoons that's going to be impacted the fuel efficiency as well as the infrastructure. And if anyone is interested, we also have a preliminary report that about the platoonable sections in the state of Illinois. I shared it with you, Marcia, so that can be applied to other states. So with that, thank you so much. And I do thank the attendees for being with us today and for the excellent questions that you have.